Hi students, this is going to help you identify if a function is linear, exponential, or neither. And I'm going to show you three different forms: a graph, an equation, and a table. So let's take a look at the graphs we have here. So again, we're looking to see, is it linear, exponential, or neither? That's as much as we've learned so far with our functions. Okay. So for the first one we see here, this is in a straight line. So linear is always going to form a straight line. So that one right away we can identify as linear. Now we have this shape next, which eventually you'll learn these. This is, we have sine and cosine functions, but this is not something we've learned yet. This is not linear. It's obviously not a straight line, and it doesn't form an exponential curve either. So in this case, we would just say neither. Now, the last one here, this one is exponential. And I want you to recall that for exponentials, it's going to approach what we call a horizontal asymptote. So one part of this graph is going to zoom up, and the other part is going to hug this imaginary line, this horizontal line. We can also look at this one, the one that I've shown you here. This is called a decay, and it is exponential. I'm going to draw you another one, and this is going to be an exponential growth. So we can see again, this is zooming up to infinity, and it's hugging this imaginary line that we call a horizontal asymptote. Okay, so it's this horizontal line here. So this one we can call an exponential growth. You always read a graph from left to right. So from left to right, if you're going along this graph, you can see you're headed up to infinity. It's growing. The more you move to the right in your x values or inputs, the higher and higher this is going to zoom up. Okay, now if we look at this decay one from left to right, you can see we're going down, 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 and getting closer and closer and closer to zero in this case. So that's your decay. Okay, so that's where you'll get a picture of a graph, and all you have to do is just identify, is it linear, exponential, or neither? Now, if I give you an equation, this first equation here is a linear equation, and I'm going to try to refresh your memory here on, so this is linear. The form is y equals mx plus b. Notice the exponent on the variable is 1. We normally don't ever show that, but that is what the exponent would be. So it's called degree 1. It's just got that one exponent. Okay, so this is linear. It's in our slope-intercept form. We know it's got an exponent of 1. Okay, this next one, we can see the exponent is 2. So this is something, this is actually called a quadratic function. We haven't talked about it formally yet. So at this point, we're just going to say that this is neither. Okay? If we had an exponent that was 5 or 7 or whatever it is, if it's not 1, and we have a different number, it's going to be a different type of function. Now for exponential, so here's the new stuff, right? Exponential functions. This form is y equals ab to the x power. If you have x as the exponent, you have an exponential function. We have this right here is our initial value, and this is your multiplier. So x is the exponent. That's going to tell you you have an exponential function. Okay, now the next level of this is looking at a table. And I think most of you have been doing pretty well just seeing the patterns in the table. That's going to be your math evidence. So this is requiring reasoning and evidence. So from the table, if I look at table A, I can see first, this went up by 10. If I want to continue that, I'm going to say up by 10. No, that would have to be 25. So right away I can say, okay, I know it's not linear because these are going up the inputs by 1, but the other side is not constant. So right now I'm like, okay, it's not linear. Let's see, could it be exponential? Is there a common multiplier? 5 times what is 15? That's 3. Now let's see, does this hold true? 15 times 3, that's 45. Perfect. Now we want to test this one out, and in fact that is also times 3. This is our math evidence. So we would say exponential. Now the reasoning part, we can say this. As the inputs, that's your x's, as the inputs increase by 1, that's this right here, as the inputs increase by 1, the outputs, are the outputs increasing or decreasing? What are the outputs doing? They're increasing, they're getting bigger and bigger. The outputs increase and have a common multiplier of 3. That's the reasoning I'd be looking for on a problem like this. You're showing math evidence with your table, and then you're going to explain what's going on with that table. Okay, let's look at the next table here. So this one we can look again and we can say, so from -4 to -3.5, I'm not really seeing a quick way to multiply. We can figure that out, but it's not real intuitive. So let's see if it's perhaps linear. So I would have to add 1/2. Does that hold true here? Yeah, -3.5 plus 1/2 is -3, and then I do the same thing here. On this side, we're adding 1 to each input. So this tells me I have a linear function. We would say the slope, this is always the change in the y over change in x. So it's 1/2 divided by 1, which is just 1/2. That's your constant rate of change. So again, let's write our reasoning. Linear. As inputs increase by 1, outputs increase by 1/2. There is a constant rate of change. That proves that it's a linear function. Okay, the last one here. So we could say, this is going down by 1. Oh, but that didn't go down by 1. So right away, at this point, I can say it is not linear. Okay? Could we do a multiplier? 3 times what is 2? It's actually 2/3. So if I multiply by 2/3, I get 2. Okay, what if I do that again? Multiply by 2/3. 2 times 2/3 is 4/3, not 3. So now this says no common multiplier. Okay, so we're going to say this is neither. There is no constant rate of change. Oops. Or common multiplier. And really, I shouldn't have erased the work I just did. So let's do, because I still want evidence here. So I'd say -1, this is a +1. So, and these are all +1s. So this, I'm going to highlight to say not linear. No constant rate of change. And you can use color when you're doing this, and you can highlight things. So if you need tools, you let me know. And then let's pick another color. I'm just gonna pick a red. So what I did is I said, we can multiply by 2/3, but this is not gonna hold true. So we said if we tried it again, we wouldn't get that 3. So we can go ahead and highlight this and say, nope, I couldn't find a common multiplier either. Okay, so that's identifying linear, exponential, the 2 functions we've studied so far. And if it's something else, you just write a neither. So from graphs, equations, and tables.